Welcome to the second episode of the topic dealing with Waec past questions. Okay, kindly subscribe to my channel to get notifications each time a new video comes out. So we are given this circle and we are asked to find the value of angle ADE. ADE. So they only want us to get this small angle here, ADE. That's the instruction. That's what they want us to get. Okay, and the question made it for us to know that this C is the center of the circle. Whenever you hear the center of the circle, suspect angle in a semicircle. Okay? So whenever you have the center of a circle, I want you to suspect angle in a semicircle. So in that theorem, I told you that angle in a semicircle gives us 90 degrees. So go and learn the circle theorems for proper comprehension of problems in circles. So this angle here should be 90 degrees because the angle in a semicircle is 90 degrees. Okay? Now, we are asked to get ADE, which is this smaller angle here. But let us consider the smaller triangle EDB. Okay? So you can write from triangle EDB. Okay? We can get this angle D since we have known 40 and 62 as the two angles. Getting the third angle will not be a wahala. So, angle EDB, which is this angle here, is equivalent to 180 degrees minus the sum of these two, 40 degrees and 62 degrees. Reason, sum of angles of a triangle, okay, is 180 degrees. So, angle EDB will give us, if I add 40 and 62, I'll be getting 102. So if I remove 102 from 180 degrees here, I'm left with nothing more or less than 72 degrees. So this angle here is 72 degrees. But I have known that the total angle here is 90 degrees. That is angle in a semicircle. So, but angle ADB, which is all this angle here, is 90 degrees. Angle in a semicircle. Okay? Therefore, to get this smaller one, I've got to remove the 72 from what? 90. Hence, angle ADB as required is 90 degrees minus 72 degrees. We are left with nothing than 18 degrees. So the required angle we want here is 18 degrees. So we are going to take another question now. Okay. Okay, so this is the second question of this episode. We are asked to get the value of angle BAD. So we are asked to get angle BAD. That is the instruction from the question. And from this instruction, we are told that this here C is the center of the circle. And if that is so, we are suspecting angle in a semicircle. And this is the chord that formed the angle and the circumference. So this is not the chord, be careful. Hence, to get the angle this chord will form at the center of the circle or the diameter, you have to move it upwards to know the size of the angle it will form at the circumference. So you have to put a broken line or dotted line to the circumference. Hence, from this dotted line I have put here, you've seen that the angle here alone is 90 degrees, okay? But all of them put together gave us 110 degrees. So first of all, let us write that angle AEB is 90 degrees. Reason, angle in a semicircle. Okay, it is 90 degrees. Hence, the smaller angle here, which is BED, angle BED will now be 110 degrees minus that 90 degrees we've got to get the smaller one here. So this will give us 20 degrees, okay? So the angle here is 20 degrees. So you are free to write 20 degrees here, 20 degrees, okay? But what we need is this angle here, angle BAD. This is the angle we need. Or if you know the circle theorem very well, you see that this angle here and this angle here are angle in the same segment. And angle in the same segment of a circle are equal. Hence, therefore, angle BAD is equal to 20 degrees. Reason, angle in the same segment. Okay, so you've seen that these calculations are not difficult. Let's take question number 3, okay? So let's take the third question. So we are given this circle with the center C, and we are asked to find the value of angle STP, ST, and P. So this is the angle they want us to find. Let us quickly mark it. This is the angle they need, angle STP, okay? We are told that here is the center of the circle. But there is a chord that can join these points of the circumference of a circle together. So you can draw a chord here to complete this triangle. Now, there is a theorem in circle telling us that the angle at the circumference is equal to the one at the center if we double the one at the circumference. Therefore, angle at center is twice angle at circumference. So let us first of all get this angle here, which is the angle at center. If you double the angle at the circumference of a circle, you get the angle at center. So you can write that angle at, which is angle TCR, will be 2 times 52 degrees. This will give us 104 degrees. Reason, angle at center is twice angle at circumference, okay? So this angle here is now 104 degrees. But consider this triangle TCR, the smaller triangle. So from triangle TCR, the smaller triangle, you know that any line moving from center, circumference to center is a radius. Circumference to center is still a radius, okay? So if here is a radius and here is a radius, automatically the two lines are equal. And whenever the two sides of a triangle are equal, the triangle is tagged an isosceles triangle. And one property of isosceles triangle is that the base angles are equal. Hence, this angle here and the angle here are equal in size. So for instance, if I decide to call the angles y, let me call it y. So it implies that y plus 104 degrees will give us 180 degrees, sum of angles in a triangle. Hence, I can write that y plus 104 degrees is 180 degrees, angle in a triangle, the sum of angles in a triangle. Y plus y is 2y, okay, equals 180 degrees. This crossing over gives us minus 104 degrees. Okay, so 2y is equivalent to 76 degrees divided by 2 to get the value of y, which I have that y is around 35, 36, 37, 38. So the value of y is 38 degrees. Okay, but what we need is not y. The total angle here will now be 34 plus 38 degrees to know the total angles here, because all these angles here are equivalent to this angle here, alternate segment. Okay, so therefore the total angle at R, okay, will be 34, as you can see, plus y, which is 38 degrees. When you add this, you get 72 degrees. So I've got this angle at 72, and this angle is equivalent to this angle, alternate segment. Therefore, angle STP, as they want, is also equal to 72 degrees. Reason, the angle between a chord and a tangent is equal to the angle in the alternate segment. Okay. So you've seen how we got this value at 72 degrees. It's equivalent to this angle at alternate segment. So this time around, let's take the fourth question before we conclude. So in this episode, let's take the last question. We are given this figure here, and we are asked to get the value of x, z, c, x, z, c. This implies that they want us to get this smaller angle here. That's the angle we are looking for. Okay, but whenever you are told that this is the center of a circle, always suspect that the angle in a semicircle. Hence, the total angle here should be 90 degrees. That is angle in a semicircle. So I can write that angle x, z, y is 90 degrees. Reason, angle in a semicircle. Semicircle is half of a circle, so you always suspect it when you have a diameter. Okay? So the sum of angles here is 90 degrees. Okay? So, but the smaller angles here can be got. Remember, any line moving from circumference to center is a radius. Circumference again to center is a radius, which means this side and this side are equal in length. Okay? If they are equal in length, it means that it is an isosceles triangle, and the base angles of isosceles triangle are equal in size. Alright? Which means that if here is 58 degrees, here must be 58 degrees. So this angle here should be 58 degrees too, because it is base angles of isosceles triangle. Hence, you can write that angle CZY, angle CZY, CZY, which is this angle here, is equal to 58 degrees. Reason, base angles of isosceles triangle, they are equal. So here is 58, here is 58. But we need this smaller angle here, like they said, XZC, and this smaller angle will be got by removing 90 degrees, which is the bigger angle, from 58, which is the smaller angle. So therefore, angle XZC is equivalent to 90 degrees minus 58 degrees. It will give us 32 degrees. Okay, at this point in time, we are coming to the end of this second episode of dealing with problems in circle theory. Kindly subscribe to my channel to get notification for the next episode. Thank you so much.
Hey there. Subscribe to my channel. And also press this bell icon.